Incredible Elon Musk discusses the world's first artificial gravity Starship. Would you ever be willing to get on board an artificial gravity Starship? If your answer to that question is yes, then this video is just for you. Man's potential to dwell on Mars will no longer be a reclusive dream for long, with an increasingly attractive technological development coming from different space agencies in the world today. With the advent of Elon Musk's SpaceX, interplanetary transportation has been redefined, with the prime focus being to transport man beyond the Earth's orbit. We believe that the artificial gravity Starship will radically change how we view the future of space travel. What kind of spaceship can make the journey to Mars? How long would the trip take? And would the spaceship require an anti-gravity system? Is it even possible? The vast distance between Earth and Mars poses a more significant challenge than we often assume. Most sci-fi movies have painted an image of how life could be at other planets as much as the reality of aliens existing. The justification of such propositions in the scientific world is void of substance, as no man has ever said food on the surface of Mars. Such physical evaluation would be the only acceptable proof of the many theories promulgated across different circles in the scientific world. One thing is sure, the atmosphere of Mars is virtually unlivable for mankind, given the natural environment. NASA's rover experiments on Mars have yielded just enough warning bells to alert us about the healthy atmospheric nature of Mars. But that is the least of our problems, as the most paramount concern is to get people over there. In the first instance, Elon Musk is virtually the leading figure with broad plans to get 1 million people to settle on Mars. Many resources have been committed to creating the perfect kind of rocket technology that can successfully make the journey without any casualty whatsoever. It would be wrong to imagine such a comprehensive project without any downside. Artificial gravity was only a fictional element until lately, when considering the long-term health of the passengers is to be considered. Why is artificial gravity necessary? And at what stage of the journey would it be of meaningful use? Scientists have learned hard lessons from several moon missions conducted by NASA in partnership with other national bodies. Prior assignments are minor compared to the scale of the Mars mission. It's good to imagine, but bringing it all into a reality is not easy. Maybe we do science fiction many bucks from opening our minds through video games, movies, and novels. Our journey into advanced technology that now includes automation and artificial technology incorporated in this space science could facilitate the development of artificial gravity. Most often think that man's push towards spatial exploration was to avoid some superficial apocalyptic climate change or resource depletion here on Earth. There is even a prediction of a famine projected on Earth by 2506, most of which will never happen anyway. The reality that man can inhabit Mars as a colony is much as realistic as the predictions of the apocalypse itself. The laws of nature won't bet many other things such as teleportation and movement beyond the speed of light or energy enough to destroy planets, but generating artificial gravity might be achievable sooner than you imagined. And it is the only physics-defying future tech that seems possible with the latest developments. We've all seen Star Trek with Captain Kirk and people on the USS Enterprise, walking like they were on the Earth's surface of the ship's bridge. Guardians of the Galaxy and most space movies gave us no explanation for why actors can act like there isn't microgravity to be concerned about in their ships. Astronauts have had to worry about their equipment floating due to the low gravity in the rockets and moon missions. They cannot sit without a restraining device to keep them in position. The biology of mankind was designed to stand on their feet on a gravity-regulated surface. Hence, we are technically out of our element in space. It messes up the physiological functions of the human body. It's called microgravity, and it poses a greater risk to astronauts' health, especially when they're spending months on space missions. We get to spending months floating around like a balloon at low gravity can do that to you. But if it's always been a challenge, how have astronauts been able to deal with it? We learned that astronauts undergo a crazy workout routine to be considered physically fit for space travel, even while their rockets are successfully launched into space. They have to continue to specify exercise routines to keep their muscles working enough to forestall extra damages to their bodily tissues. Astronauts have been reported to often return from spending a long time in space unable to move by themselves. Many also complained that they found adapting to what they were used to on Earth before the mission. Much of this is attributed to the state of gravity, lacunae space. We all understand that gravity is this immense acceleration towards the Earth center, often called 1 g for 9.8 meters per second squared. Grown up under this natural condition means that anything otherwise would have adverse effects. The journey to Mars is bound to be much more tasking than any other moon mission. It would take more than 7 months at peak acceleration to reach the surface of Mars. The SpaceX spaceship is thought to carry 100 tons of cargo when people to Mars. Regarding the safety of cargo to Mars, there aren't many questions to ask about its potential to deliver them safely to the surface of Mars. Much of the load is anticipated to be transported to the red planet before humans reach their stuff, such as housing material, rocket fuel production, machinery, food, water, oxygen, and other necessary items would facilitate man's easy settling on the red planet. SpaceX's blueprint has facilitated the development of a Starship with reusable parts, which is first the main body and carriage part of the rocket and seconded by the rocket's boosters, which provide enough traction for the carriage part of the body to lift off against gravity out of the Earth's atmosphere. The plan includes launches of at least 3 Starships and a space per day, which will foster the attainment of the goal of Elon Musk to transport 1 million people to Mars. How can Elon Musk make space travel of that magnitude safe for the 1 million passengers to board the spaceship by combating microgravity? Since we cannot store gravity or extract it from the Earth center, there is a need for an alternative source of gravitational energy. So how do we generate artificial gravity? The only answer scientists have provided none other than the centripetal force, which is the force that keeps bodies moving in a circle. It has been suggested that you keep a body spinning for long enough to generate enough energy to keep it grounded. In the case of the Starship, the spinning parts would generate enough energy to avoid the inertia that enables astronauts and objects to float in space and almost drift off. Except for the protection of the hull of their spaceship. Several blueprint structures are already projected to generate artificial gravity. Still, their construction would impact the Starship's preliminary design, making it well suited for that type of voyage. Most of these constructs are ring-shaped and large, and it would mean the rocket propulsion boosters developed for the Starship due to the additional weight of the spinners on the spaceship. A lot of thought must also be put into ascertaining what probable difficulties the rotation of the spin could pose to the energy use of the engines. These spinners would most likely have to rotate twice per minute to maintain the artificial gravity. NASA would be the first to hop on that literal ship with immense support for SpaceX as a partner to ensure the acclimatization of mankind to live in the red planet if we do get there. What do you think the chances of achieving artificial gravity in the next 5 years? Would you be ready to join the first 1 million people to fly to Mars? Let's say by 2024 or 2025. That's at the end of the video. Hope you like this video, plus thank you for spending some time with us, and please let us know in the comments section below about the video. A gentle reminder: subscribe to our channel for more content just like this one, and also press the bell icon to get notified about our new uploads.